Hello, Algebra 1. This is lesson 97. We're going to talk about angles, triangles, the Pythagorean theorem, and Pythagorean triples. We're going to go first to a definition of an angle, and that is when we form two rays together at a common vertex or common point. So in this case, this is my common vertex. I have a ray going out and a second ray going out, and what's in between them is called an angle. All right. Also, a quick reminder that when I have two lines intersecting at a perpendicular, then that is going to be a 90-degree angle if we know those two lines are perpendicular. And then another review thought, whenever we add up the inside angles of a triangle, it doesn't matter what type of triangle, those three angles should always add up to 180 degrees. Good. And then yet another review topic today is the Pythagorean theorem. This should have been something that you learned in your pre-algebra days. And it is the concept that if we take one leg and call it A, and then a second leg called B, the hypotenuse is always the C. That it follows this formula that A squared plus B squared equals C squared in order to find missing sides of that triangle. Now the last topic is probably new for everybody. These are called Pythagorean triples. What makes them special is each of these number sets, 3, 4, 5, 5, 12, 13, for example, they make right triangles with whole number sides. Okay? So why this is important is it's actually a shortcut trick that I teach students when they're learning to practice for SAT and ACT. The vast majority of triangle questions on SAT and ACT tests deal with a triangle that relates to a 3, 4, 5 or a 5, 12, 13. So for example, they may give you three sides of a triangle and you have to find the missing side. And I'll give you a tricky one here and see if you can figure it out. If I say I have a right triangle here, and I know that this side is 10, and this side is 26, but I don't know what this final side is, let's call it X. An SAT, ACT question might ask you to find that missing side. Quite a few students are going to go straight to that Pythagorean formula, a squared plus b squared equals c squared, and they're going to go through and solve to find the missing side. But if you know your triples, you'll recognize right away, this is really a 5, 12, 13. It's just doubled. So instead of having to go through that Pythagorean theorem, I would say, oh, this is a lot like a 5, 12, 13. I just need to double my 12, and so x must equal 24. Okay, so Pythagorean triples come in handy to shortcut your work and effort. We're going to go to your textbook, practice questions, A, B, C. These start on page 410. The first question is a triangle that's given. A right triangle, and it has sides 5, 6, and P, and we need to find the missing side. Well, 5, 6, those are not common triples. Okay, we're not going to end up with a pretty whole number on this one. So I don't have a shortcut way. I'm going to go straight to the Pythagorean theorem. That is a squared plus b squared equals c squared. The a and the b are the smaller legs, and it doesn't matter which one I plug in for a or b. So I'm going to write down 5 squared plus 6 squared. And then the hypotenuse is p. That's the one we'll be solving for. Go through and simplify what 5 squared is. That's 25. 6 squared, that's 36. And then add 25 and 36 together. That comes out to 61 equals p squared. Then I square root both sides. And normally you would say, oh, it's going to be a plus minus square root 61. However, this is talking about a length, a distance, and therefore it's going to always be a positive answer. And we leave it just like this. P equals the square root of 61. 61 is not able to simplify. All right, going over here to question B. A squared plus B squared equals C squared. I have a triangle with side lengths F, 5, and 15. This time you have to notice that the missing one is not the hypotenuse. Okay, it's actually one of the side legs. So I'm going to plug it in for A. I get F squared plus 5 squared equals 15 squared. And then go ahead and simplify those. 5 squared is 25, and 15 squared is 225. Now you're going to subtract 25 over, you get F squared equals 200. Square root both sides. F is going to be the square root of 200. And you'll get partial credit if you stop there and highlight it. But this is actually a square root that needs simplified. So to remind you how to do that, you break it down into a perfect square times the other factor. So 100 times 2 makes 200. And 100 is the special one that can come out of the house. It is the pretty stepsister that comes out as a 10, but the ugly 2 stays inside the house. So my final answer is 10 root 2. All right, and then question C. We have a triangle, and I know already some of my mentals are going to love these kind of questions. And I think that's a Q that's missing on this side. The question simply says, think about your Pythagorean triples. What's the missing side? So as you start memorizing them, and I highlighted the 2 biggest ones over here, as you start memorizing them, you're going to go, oh, click, that is just simply a 5. There's no work involved, and you just write Q equals 5. All right, so I'm pretty sure I have some excited mentals right now. Question D. This time the triangle got flipped upside down. I think that's just supposed to be very scary for you. I have a 6 and a 10 and an R. This time the 10 is in the hypotenuse. So if I once again look back up here, I do have one right here where the 10 is the hypotenuse. It's actually a 3, 4, 5 just doubled. Okay, so I can look at that and tell what my missing side is. R equals 8. And that's all I have to write for that one. Okay, lesson 97 is on Delta Math. So enjoy and good luck.